Today in algebra we started talking about the laws of exponents, in particular the ones for multiplying, dividing, and raising a power to a power. We worked through these notes together starting with part 1 about multiplying. It says write a to the 4th b to the 7th times a squared b to the 3rd without using exponents. So we did a times a times a times a, because that would be to the 4th, doing 4 a's, times b times b times b times b times b times b times b, and that would be 7 b's because it's b to the 7th. And then we do times, and it's a squared b cubed, so a times a, which is 2, and cubed is 3, b times b times b. That seems like a long process just to get one answer, and so I'm going to show you a shortcut here in a second. But for now, if we say how many a's are being multiplied, the total number of a's, there are 4 here, 5, 6 here, there are 6 total. The total number of b's, there are 7 here and 3 here, for a total of 10. So if I rewrite that, I have a to the 6th, b to the 10th. Now, I had them in class do this one of m's and n's. I want you to do that on your own and double check that, but when you get an answer, you should get that m is to the 7th and n is to the 3rd. Notice here that the n doesn't have an exponent. That means there's just one of them. The rule for when we're multiplying is that we add the exponents with a like base. So looking back at that first example that we did, that's for multiplying. Looking back at that first example, we took our a's, there were 4 and 2, and so there were 6. Look here, there are 4 a's and 2 a's, so 4 plus 2 is 6. 7 plus 3 is 10. Once you know the rule, you don't have to do all that writing out. Instead, you can just work through a couple of examples. We did all of these in class, but I'm just going to do a couple to highlight the high points here with you. For this one, I have x to the 3rd, y to the 6th, z to the 2nd, x, y squared, z to the 7th. So when I look at the x's, I have x to the 3rd here, and this one doesn't have an exponent, which means it's just 1. And 3 plus 1 is 4. So I have x to the 4th. For my y's, I have 6 and 2, which makes 8. And for my z's, I have 2 and 7, which makes 9. So my answer is x to the 4th, y to the 8th, z to the 9th. And that's all I can do, and that's all I'll ever be able to do to simplify. Next, we look at number 6. This one has some coefficients, 7, -1, and 2. When I have coefficients, or big numbers as we call them in class today, I just multiply those. So 7 times -1 is -7, and -7 times 2 is -14. Again, I multiply all of the big numbers. Then I take my variables and add their exponents. So x has 4 plus 2, which is 6, plus 1, which is 7. For y, I have 1 plus 2, which is 3, plus 1, which is 4. So my answer is -14, x to the 7th, y to the 4th. Let's skip over and look at number 5. I have -2 times 3 times 5. -2 times 3 is -6. -6 times 5 is -30. And I have x, I've got 1 plus 11, which is 12, plus 2, which is 14. Some common mistakes are to accidentally not multiply here, do some kind of adding or something funky like that, or the ones that have a 1. It's easy to forget those, so watch out for that. Part 2 was talking about division. The first step was to write out a to the 4th, b to the 7th over a squared b cubed. So I did a times a times a times a times b 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 over a times a times b times b times b. So I wrote out a to the 4th, b to the 7th over a squared b cubed. Then part A tells me to cancel out any common factors between the numerator and denominator. So I can cancel 1 for 1. These a's cancel, these a's cancel, these b's, these b's, these b's. Now, I picked those. I don't have to. I could have canceled this one for that one, or this one for that one. As long as it's 1 to 1, it doesn't matter, top and bottom. How many a's remain on top? 2. How many b's remain on top? 4. How many a's remain on bottom? 0. How many b's remain on bottom? 0. Nothing remains on bottom. 2 a's, 4 b's. I could rewrite this as a squared b to the 4th. And that would be my final answer. In class, I had the students do number 2, and when we did that, we noticed a pattern. Let's look on the back, or the second page, for the pattern. The pattern is that when I divide, I subtract the exponents with like bases. Subtract the exponents with like bases. So let's look back at that example. I had a to the 4th, a squared, b to the 7th, b cubed. 4 minus 2 is 2, which I got, and 7 minus 3 is 4, which I got. Some of you might be asking, well, what if the larger exponent is in the bottom? Let's look at what happens there. For the large numbers or coefficients, 13 over 26 in example 3, I'm going to reduce. The number that goes into 13 and 26 both is 13. So 13 goes into 13 once, 13 goes into 26 twice. 13 over 26 is the same as 1/2. There are more m's in the top. 6 is greater than 2, so I write the m. 6 minus 2 is 4. And n, there's more on top than bottom. 7 is greater than 5. 7 minus 5 is 2, so n squared. And that's my answer. Let's look at number 6. 3 over 9 is where I want to start. They're coefficients, so I actually am going to divide. The number that goes into 3 and 9 is 3. Goes into 3 once and 9 3 times. On this one, there are more x's on bottom than top. On top, there's just 1. So I'm still subtracting, but instead I'm going to do 9 minus 1, which is 8. And there were more in the bottom to start with, so I leave that in the bottom. 9 minus 1 is 8, and I leave it in the bottom because there was more to start with there. For y, I've got y squared and 1 on the top. Again, there's more y's on the bottom. So I have 2 minus 1, which is 1, and the y stays in the bottom. Finally, I have a z. There aren't any in the top, so it stays exactly the same in the bottom. And that's my answer, 1 over 3 times x to the 8th yz. Let's look at one more together. If I look at number 15, I've got 12 and 3. And the number that goes into both is 3. It goes into 12 4 times and into 3 1 time. I've got x squared and x squared. Well, 2 minus 2 is 0. And when that happens, these cancel fully. They totally go away. I don't leave them in either place. There are more y's on top, so I'm going to write my y, and 4 minus 3 is 1. I can put the 1, or I don't have to. Either way, that is a perfectly good answer. So, for subtraction, for dividing, I subtract. The last thing we learned was how to do ones with a power to a power. And to do that, we started by doing a cubed, b to the 5th, all cubed. And we started by writing out, which we can always do. We can always do a bunch of expansion if we don't really know how to start. That's always a fair way or a good strategy to try and remember. It just takes a significantly longer amount of time, more patience and space. But that's what that would look like. Then I need to count up all my A's. In total, there are 9 A's and 15 B's. So I have A to the 9th and B to the 15th. We did number 2 in class, and when we work that out, you should be getting, double check yourself here, pause the video and double check. 2 times 2 would be 4, and for n, we would get 10. The pattern here is that when I take the number, I do 3 times 3, which is 9, and 5 times 3, which is 15. So I multiply. So I multiply the exponents when I'm raising expressions with like bases to a power. Let's try a few examples. If I have negative 3 squared, okay, I've got negative 3 and that's squared. That coefficient, remember in all the coefficients, I've done what I would have done a long time ago before I knew these rules. So negative 3 squared is negative 3 times negative 3, which is positive 9. And then I follow my new rule. 5 times 2 is 10. For n, the exponent is 1, so 1 times 2 is 2. 6 times 2 is 12. And for q, 9 times 2 is 18. Number 4, we have negative 10 squared. A lot of people that did this tried to say that was 20. That is not the case. Negative 10 squared is like doing negative 10 times negative 10, which is positive 100. And I have q to the 5th. 5 times 2 is 10. 8 times 2 is 16. And 12 times 2 is 24. Let me show you 2 more, actually. Let's look at number 6. I've got a negative 1 as my coefficient, and that's being raised to the 8th power, which means I'm doing negative 1 times negative 1, which is positive 1, and then times negative 1, which is negative, and then times negative 1, which is positive. And I do that over and over 8 times, and eventually I'll get positive 1, which brought up an important point that any negative number raised to an even power becomes a positive, and any negative number raised to an odd power, like 3, 7, would be negative. So now I just have to do my exponents. 2 times 8 is 16, 9 times 8 is 72, and 7 times 8 is 56. And yes, those are pretty big numbers. That is okay. The last thing we looked at was ones like number 8, where it's doing 2 different things. I've got an inside of parentheses to worry about. There's division. We just talked about the rule for division being that I start with the larger number and subtract. The larger number is on bottom. 5 minus 3 is 2, and that stays on bottom. There's nothing left, so I leave a 1 on top. And then I still have to raise that to the 4th power. When I do that, 1 to the 4th power is 1 times 1, which is 1, times 1, which is 1, times 1, which is 1. Be careful there, that's not the same thing as 4. Then I do x squared to the 4th power. 2 times 4 is 8. My final answer is 1 over x to the 8. There was no homework assignment today, but tomorrow you will work on a large packet to practice all of these new rules and skills. Good luck, and let me know if you have questions.